Hey guys, today we're going to be looking at speed. And what I've got here is a simulation called the Moving Man. This is from the University of Colorado, their PhET simulations, which are absolutely fantastic. Feel free to check out their website at any time, and they have tons of stuff to teach you in very, very cool ways. But this is one of their simulations, and they call this the Moving Man. He is a man who, wait for it, moves. And what we're going to do with this simulation is just kind of explore the idea of speed a little bit. But before we get into that, let's get some definitions. Speed is what we call a rate. And a rate is a ratio of two related variables with different units. Now that sounds more complicated than it is. Think about two different things that you measure in two different ways. I promise this is going somewhere. But think the number of times someone complains. That could be like a variable. How far you've gone, that could be a variable as well. So a ratio or a rate is just a ratio, a fraction that takes those two related things and puts them together. Now here's how that's all related. Imagine you're on a car trip with a little child who is complaining about the car trip a lot. And let's suppose that for every 1 mile you travel, the kid complains 3 times. So we can make that a rate. There are 3 complaints for every 1 mile, and we can write that as a fraction, 3 complaints over 1 mile. And what that would look like is a fraction, and it is a rate. It tells you how often those complaints come for every 1 mile. I'm not sure why that's the example that popped into my head, but there you go, that's what you get. Speed is a rate as well, and speed is a rate that deals with the change in distance over a given amount of time. So distance, which is measured in meters or kilometers or centimeters, millimeters, inches, miles, whatever. So that's 1 unit. And time, which was measured in seconds, hours, minutes, what have you. You take these two with different units and you make a fraction out of them. And with speed, that fraction is the distance over the time. So in science, we most often use meters per second. So meters, that's a unit of distance, and think about this as a fraction. Meters over time, or distance over time. And that usually ends up being meters per second. And what it means is this. For every, let's say we're using meters per second. For every 1 second that passes, how many meters does the object move? So let's take a look at what this looks like with the moving man. I'm going to give him a speed. You can think of that as being the same thing for velocity as right now. I'm going to give him a speed of 2 meters per second. And I'm just going to let the simulation run, and we can play back what goes on with that. So there's the moving man doing what he does best, which is move. I'm going to stop him before he runs into the wall, as amusing as that might be. And now let's look at the playback on this. If he's traveling 2 meters for every 1 second, once the time gets to 1 second, his position should have changed by 2 meters. Let's see if it did. So I fast forward this to 1 second, and at 1 second his position is 2 meters. Now, speed being a rate, it tells us that for every 1 second that passes, in this case he's going to move 2 meters. So when we get to 2 seconds, he should move 2 more meters. So he should be at 4, so we can check that out. After another second passes, he moves another 2 meters and is at 4. Ask yourself this. Once we get to 3 seconds, where should he be? If he's moved 3 seconds and every second he travels 2 meters, I'm hoping you got to the point where you said, hey, he should be at 6, and in fact he is. So again, speed is just the rate of change of distance in a given amount of time. And we can put this in a formula, basically, where we say speed is equal to distance divided by time. And that's a very important formula that you will definitely need to remember. Again, that formula is speed equals distance divided by time. And we can actually use some abbreviations for this to make that kind of easier to use. We use V for speed for reasons that will become apparent here in a second. We use D for distance and T for time. So that equation, speed equals distance divided by time, can also be written as V equals D over T. So that's V as in Victor equals D as in dog divided by T. All right, now, I said that you can think of this word velocity as being equal to speed or being the same thing as speed. Turns out that's not entirely true. There is a difference. Speed is a scalar. It's just a number with a unit, and that's all she wrote. Velocity, however, is a vector. So velocity requires a direction. So again, the definition of velocity is it's just speed with a direction. It is the vector form of speed. Now the way that manifests in this particular simulation, I'm just going to reset this, is that in this simulation, what's used for direction are plus and minus signs. So you can see from where the moving man is, all the negative numbers are to the left, all the positive numbers are to the right. And so with the velocity, we can give a direction by saying plus or minus. So if I give him a velocity of -2 meters per second, that means he's going to move at a speed of 2 meters per second to the left. So notice that velocity has to have a direction as well as a number, and that's the difference between a scalar and a vector. All right, I hope you guys understood most of this. Make sure you try the practice worksheet on this. Make sure you have this concept down pat. This is one of the most important and fundamental ideas in all of physics. Speed is the kind of measurement that you take from here on out and is used for all kinds of purposes.